Dear students, from Elate classes, we will provide some classroom lectures on important topics of physics for the benefit of the students, and these classroom lectures will be provided in both English and Assamese medium. Those students who are interested can access those videos in our Facebook page, and those students who want to prepare for board or competitive exams by joining our offline batches, they can contact us in our contact numbers. Contact numbers will be available in the description box of each videos. This is the first lecture of that lecture series. Kindly provide your valuable feedback in the comment section of those lecture videos so that we can improve in our future lectures. Thank you for watching. Dear students, let us today discuss the topic called motion under gravity under the chapter rectilinear motion from class 11 physics. So motion under gravity comes under rectilinear motion, that is motion along a straight line. This topic we study with three different subheadings, subtopics. First one is free fall. Second one is object thrown vertically upward. And the third topic that we study under motion under gravity is object thrown vertically downward. To study these topics, first of all, we should have idea about equations of constant acceleration motion, which are also called as kinematic equations. Equations of constant acceleration motion. We should know the equations of constant acceleration motions, and these equations were where the first equation was V equal to U plus AT. Second equation was S is equal to UT plus half AT square, and the third equation is V square is equal to U square plus twice AS, where V is the final velocity of motion, U is the initial velocity of motion, A is the acceleration of motion, and T is the time taken during the motion, and S is displacement. So these are the three equations which are going to be used when we study motion under gravity. Let us now first discuss the first type of motion, which is free fall. Okay, now let us discuss the topic. It is the motion which is called free fall, or object falling freely from a height. So before we go on to study this topic, we should first know what sign conventions we are going to use? We are going to use upward or rightward motion as positive motion, downward or leftward motion as negative motion, and these sign conventions will be used throughout all these three subtopics that we are going to study under motion under gravity. Okay, so as we are studying motion under gravity, that means during these motions the objects will be under the influence of the gravity force. Now let us consider the motion parameters as per the sign conventions that to be used. In free fall, the initial velocity, because object is going to be falling freely from a certain height, so initial velocity will be 0. Initial velocity u will be 0 when the object is falling freely. As the motion is under gravity, the acceleration due to gravity is the only acceleration which will be influencing the body. So our acceleration during the motion A will be equal to G. These are only magnitude. Acceleration A, the magnitude of acceleration will be G. Initial velocity will be 0. Having these two informations in mind, let us now first rewrite the equations of motion under constant acceleration. So as we already know, the equations of motion under constant accelerations are basically V is equal to U plus AT. The next one is S is equal to UT plus half AT square, and the third equation is V square is equal to U square plus twice AS. Now when I rewrite this equation for an object which is falling freely, what I am going to do is I am going to consider these two informations in our equation of constant acceleration motion. The first equation will become basically V is equal to initial velocity will be 0, so it is 0. So it is 0 plus acceleration will be G. The magnitude of the acceleration will be G. As acceleration due to gravity is always towards the center of Earth, which is downward from our reference point of view. So our acceleration due to gravity will become minus G into T. Time is a scalar quantity. So my equation will become like this. V is equal to minus G. So my final velocity also will come as negative because object is falling freely. So the second equation will be now the second equation, let us use these informations again in the second equation for an object falling freely. So let us write down like this: S, which is the displacement, U, initial velocity is 0 because it is object is falling freely, so it is 0 into T, 0 into T plus half. Again acceleration is towards the center of the earth, which is downward, so it will be minus G into T square. So if I rewrite this equation, my equation will become S is equal to minus half G T square. So displacement also, it's a vector quantity. So the displacement, the magnitude will be is equal to half dt square, and the direction of displacement is from its initial position, it is moving towards the ground, so it will be in the downward direction. So this negative sign will represent the downward direction. So the third equation, now rewrite the third equation for objects falling freely. So if I write this equation for object falling freely, the third equation, then let us write it as v square. Now see, velocity is in the downward direction. This is v is final velocity, which is in the downward direction. Although it is downward, since it is squared, the minus sign will automatically become a positive quantity. So no need to put the negative sign here. Similarly for initial velocity u, initial velocity is also in the downward direction, but since it is squared, so it will automatically become a positive quantity. V square is equal to u square plus 2. Acceleration is acceleration due to gravity, so it is minus z and s. Finally, what we have is displacement. Now see, eventually we are going to get a positive v value here on the left hand side. So this minus, and displacement is also, since it is in a downward direction, which is also minus. So this minus and this minus, this term also becomes positive, this term already positive, and this term also is positive since it is squared. So basically the equation remains the same. So this is your third equation, kinetic equation for an object which is falling freely from a certain height. Okay, so let us now discuss few problems from the topic objects falling freely from a height. So this question is from AIPMT 2011. So let us now solve this problem based on the understanding that we have got from the topic objects falling freely from a height. Okay, so let us first read the question. The question says, a boy standing at the top of a tower of 20-meter height drops a stone. Assuming acceleration due to gravity z is equal to 10 meter per second square, the velocity with which it hits the ground is. The four options are given. It's a multiple choice question. Let us now solve this question. The question says that a boy standing at the top of a tower of height 20-meter height drops a stone. Let us say this is the height, this is the top of the tower, and height from the ground of this tower, let us say it is 20 meter. So when we solve problems from this topic, we should always draw this schematic diagram based on the given information. So let us say this is the top of the tower, which is at a height of 20 meter from the ground, and from this height a stone is dropped. A stone is dropped. In the question it is asking, what is the velocity with which this stone is going to strike the ground? This is the question. So as we know, in free fall, what we can consider? We can consider initial velocity is 0. Always initial velocity is 0. Okay. And it is given acceleration due to gravity. Acceleration A, here it is z. Here it is g meter per second square. Okay. So, how can we solve this question? We need to find the final velocity. We know the relation that we derived, which is v square is equal to u square plus 2gx, where this u square value will be 0 because since initial velocity u is 0, this term is going to become 0. So our final velocity is going to be v square is equal to 2gs, where s is the displacement, which is the object is, the stone is at a height of 20 meters. So this s is going to be basically 20 meters. Okay. So now since u equal to 0, we can rewrite this equation like this: v square, since initial velocity is 0, so u square will be 0 plus 2 into 10 into, what is my displacement? This is 20. Now see, here I am writing positive 20 and g also positive 10, but you can also write this as 2 into minus 10 into minus 20. Two into minus 10 into minus 20. Now you see, because you have acceleration due to gravity in the downward direction, which is as per our convention is minus, so I am writing this as minus 10, and displacement is also in a negative direction, so it is also minus 20. So minus minus when eventually will become positive, so directly you can write 2 into 10 into 20. So further I can write, so it becomes 400. It becomes 400. So when you take square root, you get 20 meter per second square. Now you see the magnitude is 20. Magnitude is 20. So we know when you take square root, basically what we write, we write generally plus minus of the square root value. Now here, since my velocity is, final velocity is going to be in the negative direction, I can also write with direction minus 20 meter per second. But in our question, we are only interested with the magnitude with which the stone is going to hit the ground. So my answer is going to be 20 meters per second. Okay, so let us now solve this question. This question is from IPMT 2010. So in this question it is given a ball is dropped from a high-rise platform at t equal to 0 starting from rest. After 6 seconds, another ball is thrown downwards from the same platform with a speed of v. The two balls meet at time 18 seconds. We need to calculate the value of v with which the second ball was thrown. Now, since one of the balls was actually dropped from rest, that is why I am going to solve this question under free fall. Although the second part of the question involves an object thrown with some initial velocity. Although the topic is not covered yet, I will discuss a few important points of that concept and I will solve this problem now. Okay. So first part is, anyways, it is from free fall. So for the first ball, for the ball 1, which is dropped from rest at time t equal to 0, the initial velocity is going to be 0, because it is a case of free fall. Initial velocity, let us give it a name. Let us say it is u1 is 0. Initial velocity of the ball 1 is 0. Now for the ball 2, what they have said is, after 6 seconds the second ball is thrown downwards from the same platform. That means let us say this is the platform from where the initial ball was dropped, and this is the ground. Again, draw this schematic diagram for better understanding of the problem. Let us say initial ball was, the first ball was simply dropped. Since it was dropped, so u1 is equal to 0. This is ball 1. This is ball 1. Now the second ball 2, it is not simply dropped from the same height, but it is actually thrown with some initial velocity, and that initial velocity, this is ball 2. This is ball 2, and for this the velocity u1 was 0, but for this u2 is given as v. u2 is given as v, and they have said that this height is same. That means both the balls where the first ball was dropped, whatever was the height, the second ball was also thrown from the same height, and the initial velocity for the second ball is actually v, and this v you need to calculate. Okay. Now what they have said is, the two balls meet at t equal to 18 seconds. So what we can understand from this here is that since the first ball was dropped from rest at t equal to 0 seconds, whatever displacement, vertical displacement the ball 1 has covered in 18 seconds, that displacement will be covered by the second ball, which was thrown after 6 seconds. That means basically what we can say, so let us first write what is the initial velocity of ball 2. Let us first write this thing. Ball 2, initial velocity of the ball 2 is v. And both these balls, actually they are meeting after 18 seconds. The meaning is, both these balls will cover the same vertical distance or displacement, so as to say, because since this motion is a straight line motion, displacement and distance are same, so you can either say distance or displacement for this case, for rectilinear motions. So both these two balls are going to cover same distance or displacement in a given time. That means what I can say is that S1 is equal to S2. S1 is equal to S2. That means displacement covered by ball 1 and displacement covered by ball 2 is going to be same, because the two balls meet at 18 seconds. So what we know from the equations of constant acceleration motion, S1 is equal to ut plus half at square. This equation we know. Now we are going to use this equation to solve this problem. So from the equation S1 is equal to S2. So for ball 1, what we can write? For the ball 1 we can write U1 into T minus half Z T square is equal to minus U2 into T. This minus sign is because the second ball is thrown with velocity V. So my symbol is U2. Now I am writing U2, or directly you can write V also. The minus sign is because the direction is in the downward direction. Minus half Z T square. Let us now also make some modifications to this equation. Let us take this as T1, this as T1, this as T2, and this as T2. T2 represents time taken by ball 2, T1 represents time taken by ball 1. Since the ball 1 is thrown with, dropped from the platform, so E1 will be 0. So this term will become 0. So we will be left out with half Z T1 square. Now what is T1? T1 is the total time 18 seconds, because the ball, when the first ball was dropped from the platform, the time was T equal to 0 seconds. So the first ball actually took 18 seconds to meet the second ball. Now for the second ball, what is the total time taken? Since the second ball is dropped after 6 seconds of the first ball, second ball was thrown after 6 seconds, so the second ball will take 6 minutes seconds less than the first ball. So what I can write, and U2, it is given in the question as V, so let us take it as V, and T2 is basically 18 minus 6, so it is 12 minus half into Z into 12 square. Now if we solve this equation for V, we will get the answer. So what do we get? Let us rewrite this equation like this. 12V, bringing this term to the left hand side, this minus sign will become positive, and let us take this term to the right hand side, and this term will become positive on the right hand side. So it will become half Z 18 square. So we already have this minus half Z 12 square here. So let us write it as it is, half Z 12 square. So let us take half Z as common. So we are left out with 18 square minus 12 square, and bring this 12 to the right hand side, and we'll have V on this left hand side. So we'll have this. So by simplifying, what we can get, so therefore V is equal to half Z. They have told us to take 10 meter per second square, so let us take Z is equal to 10. So how do you simplify this? Let us write it like this, 18 into 18, because in our exams we will not be allowed to use calculators, so we will have to find out some ways to solve such calculations manually without using calculators. So let us write it like this, 12 into 12 divided by 12. So from this 12 will be cancelled out. From here we will have from here what you can get, this implies V is equal to 5, half by 10 is 5 into 18 by 12 minus 12. If I further simplify it, I will get 2 6 are 12, 2 9 are 18, 3 2 are 6, 3 times, then 2 9 are 18, so I will get 27 minus 12, which is 15. 15 into 5 will become 75. So now let us solve another questions from objects falling freely from a height. So according to this question, a stone falls freely under gravity. It covers distances h1, h2 and h3 in the first 5 seconds, the next 5 seconds and the next 5 seconds respectively. And it is asked to find a relation between h1, h2 and h3. And this question actually was there in NEET 2013. So this problem is also from objects falling freely from a height. So as we already know, for free fall, initial velocity is 0. Initial velocity is equal to 0. So according to this question, if you carefully read this question, the question says object is the stone itself, but it has given the displacement covered by the same stone in 3 time sections, that is in 5 seconds, initial 5 seconds, then in the next 5 seconds and in the next 5 seconds. In the first 5 seconds, it has covered a distance of h1, in the next 5 seconds it has covered a distance of h2, and in the next 5 seconds it has covered a distance of h3. When the stone has covered first 5 seconds, as per the question, the displacement or distance covered is h1. I am repeating, distance and displacement will be same because we are talking about a rectilinear motion. So what we can write for the first 5 seconds, we can write like this. So again we are going to use this equation of motion for constant acceleration, which is S is equal to ut plus half at square. We are going to make use of this equation. So what we can write for this case, in the first 5 seconds, what is the displacement covered? It is h1. So I can write h1 is equal to, because it is a case of free fall, so initial velocity is 0. So 0, and the time considered is 5, because in initial 5 seconds the object has traveled a displacement of h1. So then we have half at square. Since acceleration due to gravity is in the negative direction, a will be minus g. So I am bringing the minus sign in the front of it. So I am writing it as half g5 square. This is in the first 5 seconds. So in the next 5 seconds, the stone has further covered another displacement of h2. So what we can write? So let us first rewrite this equation as h1 is equal to half into z into 5 square. Let us give it here equation number 1. So for the next 5 seconds, it has further covered h2 displacement. So what we can write is, so in total 5 seconds and 5 seconds, in 10 seconds, the stone will cover a net displacement of h1 plus h2, which will be equal to, so I am not going to write this part again because initial velocity is anyway 0. So I am directly adding this part, which is half into z. Now total time is 5 plus 5, it is 10 square. This is equation number 2. Then again it is said that in the next 5 seconds it has covered another displacement of h3. So we can write h1 plus h2 plus h3 is equal to minus half into z into 15 square. Let us give the equation number 3. So now from equation 1 and 2 we can write, from equation 1 and 2 we can write, because h1 is this much, so what we can write is minus half z 5 square plus h2 is equal to minus half z 10 square. If I bring this term to the right hand side, what I get is h2 is equal to half z 10 square minus 5 square. When I bring this term to the right hand side, this becomes positive. So this minus, when you multiply, you get a positive term. So what I can write here is minus half z, 10 square is 100, 5 square is 25. So what I can get is 75. 75 I can write as 25 into 3. So this becomes basically half z 5 square into 3, which is nothing but h1. So what I can write from here, therefore I can write h2 is equal to 3 h1. h2 is equal to 3 h1. Okay, so what is this term? This is h1. So h2 is equal to 3 h1. h1 is equal to h2 is equal to 3 h1. So this is the relation between h1 and h2. Let us find out the relationship between h1 and h3 now. So from 1 and 3, from equation 1 and 3, what I can write? I can write half z 5 square minus, or I can directly write h1 plus h2 as 10 square. Let us first write 10 square, because h1 plus h2 again minus half z 10 square plus h3 is equal to minus half z 15 square minus half z 15 square. So from here what I get is h3 is equal to, if I bring this term on the right hand side, this will become positive, so I can write minus half z 15 square. This term, when it goes to the right hand side, it becomes positive. Since I am writing it within the bracket, I am writing it as negative term, so I can write 10 square. This minus and minus, this becomes eventually plus. So from here I can write 15 into 15 is 225, 10 square is 100, so 225 minus 100 becomes 125. So I can write minus half z 125. This again I can write as minus half z 5 square into 5. Again we know this is nothing but h1. h1 is minus half z 5 square. So I can write here is equal to 5 h1. So one relation is h2 is equal to 3 h1 and another relation is h3 is equal to 5 h1. So okay, so what we can write, basically h1 is nothing but h2 by 3, and from here h1 is equal to h3 by 5, h3 by 5. So which option is matching? Option C is matching, because option C says h1 is equal to h3 by 3, h1 is equal to h2 by 3, and h1 is also equal to h3 by 5. So the correct option is option C. Thank you so much for watching this video.